Good afternoon and welcome to the latest BARA webinar on automated machine tending. It's good to have you along with us. Before we start, I have to read a few housekeeping rules. I'm waiting for my screen, but I'm going to read it from, here we go. So today's housekeeping rules is that this session is being recorded. We do encourage you, however, to get in touch with us. Please use the Q&A button to ask us a question, and we will try and answer as many as we can during the session. If we can't answer them all, they will be available on the BARA website at the end, which is bara.org.uk. We'd ask you not to post website URLs or company promotions in our chat box, as this will result in removal from the webinar, and you wouldn't want that. Chatham House rules apply, so a show reel from today's event, as we say, will be available on BARA along with the questions that we possibly haven't got round to. We ask you to wait until the session is ended by me, the host, and a short feedback survey will pop up on your screen for you to complete, and that really helps us for any future events going forward. So first of all, I've suddenly realised I've forgotten to introduce myself. I'm Gail Hunt from Automate UK, and we've assembled a great panel for you, and I'm going to ask the panellists to introduce themselves. So first of all, I'm going to start off with Carl Patrick.
Hi, thank you, Gail. I'm Carl Patrick from Fanuc UK, and I'm responsible for the sale and management of all systems business for the UK. With a focus on machine tending, so quite relevant for today.
Brilliant, thank you. Andrew Mason.
Hello, I'm Andrew Mason from RAR UK Automation. We, as the name implies, we provide automation products, cobots and other automation systems, gantry systems, etc., for machine tending, amongst other things.
Excellent, thank you. I'm moving now to Ben Fisher.
Thank you very much for having me on, and to those of you that have joined us, my name is Ben Fisher. I cover the Southwest for Shunk. We kind of do automation and sort of machine work holding and so on, really. So again, hopefully quite relevant to the questions you'll have come up today.
Excellent, thanks. I'm moving on to Matthew Thompson.
So you couldn't unmute myself there. Hi, I'm Matthew from Cobots Online. I'm the commercial manager here. We're a family business. We started out actually just being a CNC subcontractor originally. We've been going for about 30 years now. Now Cobots Online is essentially a machine tending integrator for cobots and robots. Yeah, that's what we do.
Excellent, thank you. And now moving on to George Thompson. The people looking closely will know, so we have the Thompson twins. I had to say it. George.
Thanks, Gail. I'm George Thompson. I'm the sales manager here for Google UK. Google have been in the linear robot industry for a few years, shall we say, since 1954. There's not many applications that we don't get involved in, whether it's machine tending or anything else. And also, for all my sins, I'm chairman of BARA as well.
Lovely, thanks very much. So let's start at the beginning, and we're going to first of all ask what machine tending applications are most suitable for robots. So what kind of work is the best? So I'm going to start that with Carl.
Okay, thank you. Well, I think anything that is a highly repetitive nature, and I know George is going to agree with me now with the 3 Ds, anything that's deemed to be dull, dirty or dangerous, where it's very difficult to keep someone engaged with a task. And if it's repeatable in nature and it's quantifiable what the variables are, then it's relatively simple to program variables out. So it's really, yeah, the repetitive nature and then de-risking a process to make it sort of repeatable.
Okay, lovely. Ben, would you agree with that? What would you say?
Yeah, I mean, to be honest, I think Carl's kind of hit the nail on the head there. I mean, I think volume can play a bit of a factor. Obviously, it's easy to kind of automate the similar sort of components. There's less sort of variables you have to kind of consider. But again, really, it's trying to give those skilled tasks back to your employees and taking away those tasks that perhaps don't need that level of skill that effectively you're paying your employees to do. So yeah, hopefully it's kind of looking at those opportunities where we can get people doing what they're good at and kind of leaving those tasks up to robots.
Okay, yeah, because so repetitive is just, you know, it can be mind numbing, can't it? If you're doing a task, the same task over and over again throughout a shift. Matthew, what would you like to say about the best things suitable for it?
Yeah, well, as Ben and Carla said before, high quantities, low mix parts, you know, perfect traditionally for robot and cobot machine tending. But more recently, we actually finding that we can do a lot actually with the high mix, low volume. The way that we're using all different products together means we can actually, you know, if we have 100 off or a 200 off of a relatively simple part, or a customer does, we can do that quite easily. The new ways of programming the robots and the cobots is that easy that it's just within less than half an hour you can set up to do a different kind of job.
Okay, brilliant. Andrew, let's talk about actuals. We've talked about the kind of jobs, but are we talking about lathes? Are we talking about metal? Or what are we talking about in these?
From a sort of focus of maybe the machine, the owner of the machine shop or the factory owner, their focus, if they've invested in a lot of money in machinery, they want to keep them running. And
Yeah.
so I think it's sometimes the shorter cycle times where you traditionally have a person loading the machines. They can drift off, get talking about last night's football or whatever. So you lose productivity that way. So I think they're probably the focus machines where you've got not maybe a bar feed lathe, but maybe obviously a billet lathe, because that needs attending all the time. I think that's a good application. Vertical machining centers where you haven't got maybe twin chucks where you can't preload them. But then also we can think about other machinery like injection molding invariably has axis an axis system picking out the product. Also metal forming machines, press brakes, and even inspection machinery, loading inspection machines can be automated. So there's a wide range, but I think we're all very much thinking about machine shop, but there are other areas.
Okay, George, do you agree with that? Yeah.
Yeah, absolutely. There's any number of different industry sectors that we can be looking at. It doesn't have to be metal. It can be wood. It can be plastics. It can be anything. And again, it comes down to the repetitive nature, as we've already said, and also when you look at the manual handling element of it, you know, you have the compounding of every move that you make, which can cause injuries further on, with the operators. And the last thing that any of us want is to have operators go off injured. Long-term sick doesn't do anyone any good.
Yeah.
So let's take them out of those dull, dirty, dangerous applications and get them in more value-added situations.
And generally just less boring. Yeah.
Absolutely. Who doesn't like watching robots work? Just saying.
Okay, so we've set the scene on that, but I'm sitting here thinking, "Ooh, robots! What are the safety challenges if we're using these in these applications?" I'm going to come to you, Carl, first on that. The safety challenges.
I think it's a case by case basis, because although you might have 10 inquiries on a CNC lathe, for example, the nature of what the customer or the end user really wants is going to dictate what safety requirements need to be assessed.
Sure.
So if the part comes out sharp, then it needs to be guarded. If it's a slow and it's rounded, then perhaps a light curtain might be. But regardless of that, it needs to be assessed. Every application needs to be assessed, and everyone will be different in its own unique way. So I would just recommend anyone that's considering anything to get in touch with any one of the people on the panel today and let us assist you in making an informed decision about what needs to be considered.
Okay, I mean, and also because BARA as an umbrella organization is a really good contact point that we're all talking about today, isn't it? So, you know, you're not going to be sold to, you're going to actually learn about what you should be doing in your own factory rather than, you know, being, oh, I'm not going to talk to them as they're just going to sell me something. I think this panel isn't going to be like that.
Right.
So Ben, we talk about light curtains there, or even cages, but any other safety challenges that you've come across when you're supplying your customers?
Yeah, I suppose one of the big things for us will probably be sort of weights of components. Obviously, that plays into the actual gripping and picking of components. So there's more forces required. So again, it's kind of mitigating those risks and finding safety features around that to kind of reduce pinch points and like I said, guarding things like that to protect you from that. But yeah, it's definitely one of those things where there's no sort of standard for it. It's very much based on the component you're picking, size, weight, and obviously what you're loading into as well. So yes, yeah, difficult one without sort of seeing.
Yeah, without the actual application in front of you. Anyone else want to come in on safety at all?
I think Ben. Sorry.
Sorry, go on, Matthew.
Yeah, I think Ben and Carl have pretty much just nailed it there. But something that we use a lot of is, you know, we use like the safety laser scanners. So predominantly everything we do is with a cobot as opposed to a robot, which, you know, is supposed to be collaborative. Although when you're the boss of a machine shop, you don't want the robot going at a collaborative speed because it's, you know, it's quite slow. So, yeah. So we, you know, we risk assess every job like Carl was saying. And where we can use the scanners, we can have the robot or the cobot going, you know, at full speed, but then through the risk assessment, we'll determine the zones, you know, for the reduced speed zone and the stop zone. So that sort of mitigates it. If it's nothing that's too sharp or anything, then you don't need the caging and everything like that.
Yeah.
Which obviously helps us with the things that we do in the customers. Be able to do the low mix high volume things because you can be doing different machines. It's not a set up on one machine that has to stay there with a cage around it.
Sure.
Everything's getting better and better these days to make these things quite easy to do.
Okay, George.
Yeah, I think all of those points are very valid. One thing to bear in mind, of course, is that it's everyone's responsibility for safety. It's not just whoever is employed to deliver the automation for this. It's also the directors of the company that are employing, if you like, the robots or automation in general, that they are responsible as well to make sure that it does adhere to all of the machinery directives and safety standards and so on and so forth. And that's not to scare anyone. It's just, you know, you can't stand in front of a judge and say, sorry, I didn't know. That's not an excuse. You do have to understand what the safety implications of everything that you do is. And that comes down to getting a good quality integrator who knows and understands exactly what is required for the various applications.
Okay, because you know, at the end of the day, if someone wants to do something quickly, you know, as an operator, you might cut a corner or you might do something that, you know, is supposedly not allowed, but then you're mitigating against that.
Yeah, absolutely. Yeah, you kind of have to protect the companies against those who are looking to cut those corners. And what a lot of people don't understand is that the guarding isn't there to protect the robot. It's there to protect the operatives from getting in the path of the robot. And again, not wanting to scare anyone whatsoever, but you know, if these things aren't guarded correctly or the safety implications aren't in place correctly, then they're going to squish you and not think anything about it. Plain and simple. And I've seen people stuffed into machine tools, you know, because they have cut a corner and they have, you know, bypassed the safety to do something quick, and it literally bit them.
I'm assuming systems today have moved on and the safety systems are better than that now and won't let you do that.
As long as they're implemented correctly, yes.
Yeah.
But you know, it's something that people have to be aware of, is you know, there's always going to be someone who will try to defeat the safety. And as integrators, we have to try to mitigate those risks by implementing the correct level of safety for what is required for the applications.
Okay, so on a more positive note, going so I'm looking here, what working holding solutions are required and how do they interface with the machine and robot? So when we're talking about holding solutions, now I know someone's really good at this. Now, who's that? Ben, I think. Is that you, apparently? I have
Yeah,
worked.
let's go for that. Obviously, in terms of work on how we kind of approach that is not too dissimilar to how you would do it in your manual process. Obviously, the big difference here is how we power that sort of work holding. Typically, we would look at pneumatic solution. Reason for that is it's in machine tending or in most sort of environments, industrial, there's always a pneumatic supply there. So it's very easy to kind of implement. It's very easy to control, but it's also good in the sense that there's a large range in it. You also can have 3-jaw things, you can have 2-jaw sort of vices. But we can do things where we can feed the robot. If you don't have the ability to actually have air supply straight to that particular work holding item, we can feed that through the robot. So now all of a sudden you can take a relatively dumb machine, a 3-axis machine with no table services, and you can provide those services via the robot. So we're kind of giving automation to areas where potentially before it's not particularly possible. But that's kind of not the limit on it. Obviously, hydraulic is another way that we can do that. And electric is starting to become more and more popular because of the kind of control and the range of motion you get on that.
Okay.
So it's rather vast in what you can do, but obviously linking it into machines, controlling it can all be done via machine control. So you're keeping the kind of work holding side of it in the machine, and you don't need the robot as such. So you're giving again those operators something they understand fully, which is the machining side. So we can link that into the M codes and feed the air through the machine. But really, it's kind of done on a very similar sort of approach to how we would look at your standard process. And now we're just adding that automated solution via some form of media feed through.
Yeah. And so that is becoming more and more popular, or, you know, people are definitely wanting this.
I think what's possible is becoming ever expanding, really. Obviously, typically one of the limitations might have been you finish one job, now you've got to change the fixturing. That can all be done by the robot now. So using 0 points, we can change between fixtures, we can do automatic jaw changes. Even on things like lathes now, we can change the chuck jaws from op 1 to op 2, all of that in an automated process. So there doesn't need to be that involvement to change between jobs. And obviously with grippers as well, you can do the same thing. So you can kind of keep all of that process, inspection, everything in an automated cell and have it running lights out to give you that full automated production. And obviously with the development in terms of cobots and how you program them, it becomes even easier to program the robot.
Okay. Carl, what would you like to say about holding solutions?
Well, Ben touched on a really interesting point there because, as we said, they're repeatable and getting a consistent product. Even if someone's very early on in their journey into robotics or automated machine tending, that adds another element of consistency, because I'm sure that me and Ben would do the same job and we'd do it differently. If we weren't using a torque wrench to tighten a vice, we're going to clamp it differently. So again, having the right work holding, the right work handling, it adds the consistency, which then transposes into the finished product, which is another reason to automate, because you know what you're going to get every single time that cycle's finished. But a consistent product off the machine, and that is all down to the handling and the holding.
And also, especially with a precision product, rather than, you know, I know everybody wants all their shampoo bottles to look the same, but if they're not, no one's, you know, that's not going to not fit anywhere or whatever. This is precision things you're dealing with, isn't it? That matter.
Yeah, of course. Yeah. So a lot of these products, they're going to end up at quite a expensive product, and the time of manufacture is costly.
Yeah.
So you can't afford to be producing scrap. And ultimately, if you're going to put a big cut onto a piece of material that's held poorly, that's going to damage your work holding, damage your machine and your tooling. So it's very important that you build the foundation of any automated process right from the very ground up.
Yeah. Okay. What about Andrew? What do you have to add on work holding solutions?
Okay.
From a cobot point of view, maybe, yeah.
Yeah. Okay. Well, a couple of things I was just from experience of places I've been to and seen. Ben talked about changing jaws and grippers, etc. One particular customer I went to, they changed their sort of billet design, so they always went with the same size to sort of, and they lost they lose a bit of cost in waste of material and a bit more extra machining, but they got consistency of loading. Loading a 3-jaw chuck is the simplest way to load anything because it's self-centering. I was going to also just touch on getting rid of swarf is an important thing. You get a swarf underneath the component, and it's not going to sit right. It's not going to be sort of in the right position, and then you may lose accuracy. So that's normally having air blasting to wash down effectively. This is in machine shops, obviously. The other thing I was going to just touch on is, and I like to always think about this with a robot, is to pull it back into what a human would do. There's 2 senses that a human will use generally loading machine, and that's their eyes for vision sensors, which you can incorporate with robots so you can find the component to put in place. But secondly, I think probably more importantly is actually force. When you load something to a vise or a chuck, you want to feel it's in position, and you could feel if there's a bit of swarf underneath it. So, and robots now have force sensors and techniques to make sure that the product actually goes into the right location. So you can put a pin in a hole, for example, by searching for that hole.
Okay.
So there are a couple of other features which haven't quite been touched on, which I felt might be worth mentioning.
Sure. Is that relatively recent, or has that been going on for a while, or?
I don't know so much about force sensing in the more industrial robots, which Carl may know more because of Fanuc in more industrial robots. But certainly in the cobot world, we have force sensitivity built in, and then software techniques which allow, and one is called a spiral search. So if you're looking to put a pin in a hole, it looks for the hole effectively until it finds no resistance in force, and then puts the pin in the place.
Right.
And that could be used to find, to push a billet up against maybe a stop, or make sure it's in the right jaw, or down in the chuck, for example.
Okay, Matthew, so that basically the technology is moving on all the time, you know?
Yeah, like Andrew was saying there, with the cobots, you can use the force. We actually, so although we're an integrator, we also have 4 of these, of what we call it, 4 of our systems within our factory as well. So we can use the cobot as much as we want with either, vision or the force to check that the parts are in the work holding correctly. But we also, we employ probing on all of our machines. So all of our machines have like Renishaw probing on. I'm sure there's plenty of other brands out there as well, which means that we don't actually have to be as specific when we're picking up the parts and putting them in the vise. We can put them in the vise, and then the probe will come down and it will check exactly where the part is.
Right.
And if there's a problem with it, it'll identify that. So if, for example, someone's put a bar end into the fixture, when the cobot puts that into the vise, as a human might do one day, the probe will come down and it'll actually check that that's not, that it is the right size. So it's not going to come down and smash the face mill to bits or something like that.
Okay.
Yeah.
George, anything to add to the working holding?
I think we've covered most of it. I do agree with what Andrew was saying about the vision. It's come a long way since I started out back when Moses was a lad. There are things that we can do now that then were just a dream, and technology is moving so quickly, especially with how AI is coming into play and so on and so forth. It'll be interesting to see where the next 20 years takes us.
Sure. So with the advancements, of course, I'm assuming that some of those advancements are to make it easier for people to adopt these systems,
Yeah,
rather
absolutely.
than having to be a super qualified engineer or whatever. Okay, so moving on to robot tooling or grippers. What are the most common ones used for machine tending? Who would like to come in on that first? Maybe Carl. Carl.
Oh, I was sure Ben was going to pipe up then.
I know. He got first
I
dibs
thought it'd
last.
be rude to take two in one go, so I
Yeah,
thought
exactly. He was first last time, Carl. You'll go first this time.
Okay. Well,
So, I mean, obviously, you use all kinds of different things
Yeah.
on your equipment.
so there's a number of suppliers. I mean, we all have our preferred suppliers of these equipment, but I think the key thing to do is engage with the people that you're going to get the equipment off. And as we mentioned before, no application is identical to another application. So it's really understanding what the terminology means as far as weight capacity, understanding the stroke that you're going to have on a 3-jaw gripper, for example. If you've got 5 mil of stroke, but you're uncertain about the position of the billet within 6 mil, then that's not going to work. And that's where the vision might come in to true up that position before you try and pick it up.
Right.
So these are the considerations that you need to make beforehand, because like most people joining in, I'm assuming, are going to be machinists, so they're going to understand a stack of errors and what that can lead to. So it's trying to mitigate every step of the process, and that could be having a regrip station in between the initial pick and load into the machine, just to qualify a datum face. So, but gripper selection is obviously important, and a lot of it will be around the capacity of the robot, and then the actual fingers that are implemented onto that gripper is what an integrator or the end user might modify to suit the next part that they're going to produce.
Okay, thank you, Ben. I have to come to you now. You've
Yeah,
had
no, it's good. It leads on quite nicely from Carl. So building on what Carl said, in terms of sort of gripper selection, typically, obviously, weight, big factor, payload of the robot. But in that weight, you've kind of got to consider, obviously, the weight of the gripper itself, any potential tool change, and any adapter plates you might have. Rather frustratingly, it tends to be that there's no sort of standard robot flange that mounts sort of different size grippers. Every application changes, so you're forever needing sort of an adapter plate in between there. Which again adds to that kind of weight that eats out of your payload. So it's always a consideration to have in mind when sort of looking at your robot. But really, environment, obviously where that gripper is going, do we need a specific IP rating for it? And then the stroke of the gripper in terms of components we're picking. And then finally, sort of the finger length. And obviously, finger length being very important in the sense that too long a finger length puts too much sort of moment on your base jaw and causes problems. But
yeah,
it's all within reason. Obviously, you can get multiple products using different fingers. Multiple products out of the same gripper using different fingers. It's just sort of being aware of those factors and kind of building them into anything you kind of do, really.
okay. And anything is possible, basically, within reason. You know, you can
Yeah.
do anything.
Typically, obviously, 2-jaw, 3-jaw, 4-jaw is the way to go, but they're what we understand in terms of basics of operation. But we have magnet solutions. We have things like gecko grippers now, which use no actual service at all. So there's no air supply to it. There's no electricity to it. It's purely using sort of similar features you find in a gecko's foot. So yeah, it's really kind of ever evolving. And again, it's one of those where application driven. But in machine tending in particular, yeah, your sort of 2-3 finger grippers are conventionally what you find, because you're following that same sort of principle you find in your vices and your chucks to pick up your round and square components. So
Yeah. As long as they're better than those things in fairgrounds, you know, where you're trying to pick up the soft toy.
No, yeah, and obviously force is another thing to consider on that, as you kind of touch on that.
Yeah.
Making sure you've kind of got adequate force, obviously, when you do run the robot at speed, to make sure you've got that component and you will have enough force there to kind of hold on to it. Obviously, factoring e-stops, things like that, adds a lot of sort of load onto the end of the robot. So, yeah, even though on that, end of arm tooling kind of covers everything. I think you touched on force torque sensors, tool changes. Again, we have the ability to kind of change between components. If you want to run square to round billet, we can change the jaws, change the fingers all automatically. So automation is kind of going that way where everything now is becoming possible. Obviously, yeah, we'll reach out to kind of integrators and see what they can come up with, really.
Yeah. Okay. George, talking to you about grippers, I mean,
Yep.
in this way, Do you have to have a different one for absolutely everything, or is there a universal one you can just go, oh, I bought this, I'm going to have this gripper, or is it all bespoke?
I wish. There are so many different factors, as everyone has already alluded to. You know, it's the size, it's the shape, it's the material, it's the temperature. You know, are you loading it into a furnace? Are you taking it out of a furnace? Are you putting it into a CNC lathe? Are you putting it into, is it a wood substrate that you're loading into a flat CNC router? There's never one right solution for everything, and you have to do gripper trials for everything that you're doing. And that's part of where, as system integrators, that we would all come in and we would do those trials, and we would make sure that we have the best solution we can for that particular application. You know, unfortunately, there is no one size fits all. You know, it really does depend on how we need to grip it.
Sure.
I wish there was.
For sure. So if I'm sitting here thinking, oh, I want to start machine tending, I'm going to get this robot, and then I need a gripper, and have I got this? And you know, could I come to any of you as robot suppliers and grippers, obviously, but to sort it all out for me? Matthew, is that something I could come to you to say, or because even
Yeah.
if you don't do it, you know a person who does, or
Yeah, that's exactly what we do, and that's actually how we became who we are. So as I said, we are a machine shop originally. We've had robots in the past, and now we have cobots. But 4 or 5 years ago, we realised there was a market for integration as such to bring it together. We bought a cobot, and Tony, our MD, he thought, oh, this is brilliant, this is great, to revolutionise the company. It got delivered in a box. So what we saw it doing on a machine, it just turned up in a box. We had no end of arm tooling, there was no safety, there was nothing to put it on. We didn't have a clue what we were doing with it, and that's actually where the Cobots line was born. So now we work with we work with Shunk, we work with Fanuc, we work with Universal Robots, Robotique, and we're kind of like a hub for it. So if you're looking to do some machine tending, we're like a partner with a lot of these people. So although they like I don't know, like Carl, for example, at Fanuc, he might sell a machine to someone and they want some automation. So Carl could do that, or Carl might actually pass them on to us, for example, and say, okay, we'll sell you the machine, but if you go to Cobots Online, they'll do the whole sort of solution. So they'll send them the right machine for the job, and then we might sell them the Cobot with the grippers from Shunk, with the safety from wherever that might be, so that when we leave, the customer's they've been trained on the Cobot, and they've got the end of arm tooling, the safety. We've helped them, the risk assessments. When we leave, the robot is making parts. They're not just getting bits in a box and not knowing where to get the next bits from.
Because it's in all of your interests, isn't it, to all talk to one another? Because you can't sell grippers if you haven't got a robot. You haven't, if you haven't got anything on the robot to do the job necessary.
Yeah.
But is that a barrier for people to to actually start adopting robots, or because they just don't know where to start?
Yeah, I think it is. I think a lot of people in the past have actually just tried to do it themselves, like we did, and then the robot sat there in a box for 6 months because no one has a clue what to do with it. And then a lot of the time, with a lot of our customers, we actually we'll go to see them, and they'll have been scared off it by either they'll have had one in the past that hasn't worked very efficiently, or they'll know someone else who's got one and say, oh, I wouldn't want to buy one of those. It's it doesn't do anything, but it's the implementation that needs to be correct to make that happen. We've seen it lots of times where the customers are coming to us a bit scared, thinking, I think I'm just going to buy one of these systems for X amount of money, and it's not really going to do much. But that couldn't be further from the truth, realistically, because everything's out there now, and everything, all of the other systems work really well together. So Shunk will work really well with Fanuc, will work really well with the machines. So the way that we can integrate it, you don't need to be an expert in each manufacturer. In fact, you don't even need to be an expert in robotics these days to be able to use the manufacturing.
Okay, well, good that everyone's talking together on that, because obviously I do think that is an issue, isn't it? That where do I start? on the journey to it. So I've got a question here about communication. So how does the robot and the machine communicate? Because if you've got a control system on your lathe or whatever it's doing, how does the robot fit in with all of that and whatever? So let's talk to Carl about that.
There's a lot of different protocols that you can use these days. One of the most popular ones at the moment is Ethernet IP, which
Okay,
is
yeah.
a communications protocol. But for older machines that maybe don't have some of these more modern options, you can still do what you call a hard wired interface, which is effectively looking for a 24-volt signal from the cycle start, for example, and we can see that the machine is in cycle, or put a switch on the door to say that the door's been opened.
Yeah.
And so really you can automate really old pieces of equipment. The only drawback to that I'm sure Matthew's seen before is people normally run that machine for maybe 8 hours per day, and now they want it to run 24 hours a day, and it's 20 years old already. And it's quite a harsh environment to ask a relatively old piece of capital equipment to start working 3 times as hard as it ever has done. So it is possible, but I would suggest maybe it's more practical to do it on some of the newer pieces of equipment.
Right. Okay.
Longevity.
Okay.
Could I just sort of just make a point on that? Sorry to interrupt, but
No, go.
Yeah. So this doesn't necessarily go so well for Cal's sales as such, but we actually implemented a cobot on one of our oldest machines that we were actually going to, we were going to scrap it. It was that slow. It takes ages to speed up and slow down. If we put an actual operator on it these days, we're just wasting money because we have to run it quite slowly. We've actually put a cobot on that recently, and it does run 24/7, albeit not as quick as the other machines, but it probably churns out more work than any of our other machines now.
Because it runs 24/7.
Yeah, maybe not exactly 24/7, but in our factory we run 18 hours a day, and we don't actually set them up to run. We don't think, oh, you need to set this automation up to run for a week without being touched. Most of the jobs we set up run between maybe 6 and 12 hours, depending on the size of the parts that you're loading in and taking out. So when our guys, when our late shift finishes just before midnight, they'll actually load up the jigs on the machines with parts, and then that'll either just finished or just be carrying on in the morning, when the guys come in at 6 o'clock again in the morning. So we have it. We do have them on our new machines, and the way they integrate with the new machines is brilliant. But you can actually use them on, like I say, I think one of our machines that we're running it on is probably 30-year-old. And like I say, we were going to chuck it out, but now it's a savior. It's brilliant.
Okay, cool.
Yeah. But we don't flog it as well. We are careful with it, but it doesn't matter if it's going a bit slower because it's not. It's not going for its lunch. It's not finishing at 5 o'clock. It's just chugging along all the time.
Yeah. Andrew, communication.
Okay, well, some bits have been touched on about wiring hard into the control. I think that can give you some potential implications on safety, because the machine tool manufacturer may not want you to wire into their control in case you're interfering with maybe interlocks on the doors.
Right.
We have with the companies we work with, one solution around that, which is quite recent, is where we sort of bypass that by having sensors which look at the operation of the machine. So we can look at the light stack to tell us when the cycle's ready to go or stopped, and then we can put in pneumatic devices to actually replace the man. I press the start button, but you can do that in other ways. You can open the door, actuate the door with a device, and even close the chuck with where normally you press a foot pedal for closing the chuck if we're talking about a lathe. we can actuate that through pneumatics, and then we have a control panel, which so it effectively does what the man does without actually getting into the machine control. And it knows the cycle because it's looking at a stack light. You're dependent on a machine having stack lights, but it's probably a way for working on older machines, particularly. Sorry,
which haven't got as sophisticated control systems themselves. Yeah.
Some of the newer machines will have a field bus interface. Carl touched on that. He mentioned Ethernet IP, I think it was. I was going to also touch away from the machine centers, but maybe injection molding machines. I'm not expert on this, but they have a system called Euromap 67, which interfaces robots with the injection molding machines. So that's a protocol which exists in that world.
Okay. George, what about machine and robot control and communication?
I think everyone has touched on it very well, and covered it to death type thing. One thing and Gail, you've heard me talk about this before. One thing that when you go around factory tours in Europe, they want to take you to their most spangly, newest, most efficient bit of kit that they have. And here they want to take you to the oldest piece of equipment they have in the facility, and are proud of the fact that it's 100 years old and they still have people who understand how to use it.
Yeah.
And that, I think, is the bit that we collectively need to change. I know make, do, and mend is good for the environment and so on and so forth, but we also have to make stuff if we want to be competitive on the global stage.
And you actually, even talking about the environment, you have to make stuff the most efficiently in terms of material inputs and wastage and water stewardship and all the other things, don't you?
And not shipping it halfway around the world.
Yeah, that's another thing.
Yeah.
Right, I'm going to move on. So how is the system best programmed? So, if you're thinking about technical side, is it offline, simulation on the machine, or a combination of these? What would you say, Ben, is the best way?
Well, really, I think if you're depending on looking at the robot and how you're doing it, depending on the task you're doing, things like cobots nowadays make programming so easy just by simple drag and drop. So if you're kind of hands-on, you can kind of see exactly the application you're trying to do. You can move that robot around, and it doesn't take long to do that on the controller at all. Obviously, I think industrial ones, Carl will know a bit more about that than I will in terms of the software behind it. But yeah, I think there's kind of so many options out there for you, and even integrators themselves doing it for you. It's very easy and very accessible. And cobots in particular have made that particularly so for the end user.
So people shouldn't be scared of lack of skills in that area, because
no, not at all. The training that you get with these robots nowadays, again, gives you a very good understanding of exactly how to operate these things. So absolutely, yeah.
Okay, Carl, I'm assuming, because I know FANUC do lots of training in this area as well, so that you're not just delivering the box and leaving it like Matthew had. You're actually holding people's hands until it's all working.
Yes, so we obviously sell the robots, and a lot of our people that buy the robots are actually integrators like Matthew, but we also do the full service, so we'll do a full turnkey package for a system, and we'll build that in our premises in Coventry and then deliver it when it's working. But also for smaller people that are on that journey on their own, we'll do the full training cycle. So from someone that's never seen a robot, within a week they're programming a robot, and then we do lots of ancillary courses for different elements of it. And to go back to your question, I think it's the same answer I've given before. It depends. If you're doing low volume, high mix, then there is a lot of integrators out there that will give you a platform which makes it very easy to input billet size, grid pattern, pitches, and where it's going. And you basically answer questions, and it becomes quite a conversational way of programming.
Okay.
Not scary at all. But if it was a cell that's only ever going to do one component for the next 20 years, then perhaps all of that glossy, nice easiness isn't required, because it's not going to change. So again, I suppose it's who it's going to, and what is their mix of products going to be like. Because I don't, with Cobots Online, the idea is to do a batch of maybe 20 and then change the tooling or change the program to suit the next component. And the quicker you can do that, the quicker you're earning money again.
Yeah.
So it really depends. And lots of integrators have got their own method to offer.
Okay, so because certainly, you know, it's almost like making sure you're having the appropriate technology, isn't it? Rather than you don't always want all the whistles and bells and everything on for every application.
That's it, exactly right. And yeah, if you can ask the limited amount of questions that get you going, as in shape, height, quantity, pitch, that's normally enough to actually get you going. And yeah, it just builds from there.
And then you can add to it, you know, if you buy the basic, you can still upgrade later, I'm assuming. So it's not like you've got to decide at the beginning to go straight for the Ferrari. You know, you can get the Fiat 500 to get you started or whatever.
And I'm sure, again, Matthew's going to agree with this. I think a lot of people that have really done really good examples of implementing from no automation to having a lot of automation are those that are focused on getting a little win, get internal buy-in, see a successful process, and build on it, and then start tackling the next low-hanging fruit. And that's a good way to adopt it throughout a workshop.
Right, for machine tending and all kind of robots, isn't it? Sort of baby steps, baby steps. Yeah. Okay, George, what do you think about programming? Is it offline simulation? What do you recommend?
I think it depends on the application. I think it's more about the right level of automation at the right time, as has been alluded to. So many times that we've all gone into factories and they say, no, we want it lights out. And then when you hit them with you realize this is going to be a significant investment. Let's start small. Let's get the confidence in what we're doing. Let's get to know each other. Let's build that relationship from there. That is more important than the programming element, in my opinion. And there's a lot that can be done with the HMIs, for example. You know, collaborative robots, yes, are more easy to program than some of the others. But it depends on what you're doing, whether a cobot is the right solution or whether it should be an articulated robot. Should it be a linear robot? And it's about getting the right piece of kit in at the right time to make sure that you have the best success you possibly can.
Brilliant, thank you. Right, well, I'm just going to, we have a few questions that have come in. So I'm going to hit you with these. These are always nice surprise ones for the panel. Right, so this is a good question actually from somebody. How would I know if automated machine tending is something I should be implementing on my machines? You know, the person sitting there, as they have said, you know, how do they know what's happening that they need to change? I'm going to come to Andrew. Shall I come to Andrew? I haven't spoken to you for a while.
You can do, yeah. I generally say you need to engage with suppliers to come and visit you. The sales guys will normally have good experience of previous applications. They may have seen something similar. They may look around your workshop and say this task is good, and that one I would not consider. So use their experience. Then it's normally 3 because they're trying to sell you something ultimately. But when they say it's ultimately trying to sell you something, generally their advice we want to sell you something that works. They're not going to sell you something that's not going to work. So I don't think you should be cautious of that. And then you could also engage with people in organisations such as BARA. You know, the members there have got a lot of experience, and yeah, so that's why we offer these sort of webinars.
Yeah.
So engage with the suppliers, and I think that's the way forward.
Okay, so if they're sitting there thinking, oh, I'm not sure whether I need it or not, that would be a good sort of independent place to start. Do you agree with that, Ben, the way to do it?
Yeah, I suppose each individual person is going to know sort of their company and their process best. Obviously, suppliers will be able to advise and based on applications seen before. But ultimately, if you're seeing a potential there where you can run those machines for longer to get more production, and you have the need for that, then absolutely, I think obviously automation is something that's worth exploring. It's typically nowadays there's a lot of processes that can be automated, and if you're kind of seeing that need where you think, you know what, actually we do need more production, or we do need this process done quicker or for longer hours, then 100% it's something that's worth exploring.
Okay, brilliant. I'm moving on to someone else who's asked, what are the current blockers to companies that should be implementing automated machine tending? So what is it that stops people going for it when really they think they should? I'm going to come to you, Carl.
I think it's one of the main ones is the perceived cost of doing something. But I've done no end of calculators based on people's products and manned hours compared to unmanned hours. And actually, I think that the mean time on a machine tending, depending on the average amount of time you're going to get extra, where it's running without any supervision, or deploying someone to a more value-added task, it can be as little as 6 months up to maybe 2 or 3 years to get complete payback on that product. So the other thing was a blocker. It was that it was hard to get finance on automation systems because it's a bespoke bit of kit, allegedly, whereas that's not the case anymore. And you can get capital equipment finance on systems and system integration. And I think you touched on the previous question. It's people not knowing that what they are doing is perfectly feasible.
Yeah.
Really. So I think they're the main blockers. Really.
Okay. Matthew, what do you think the blockers are? Similar?
Yeah, as the guys have already said, there's, you know, the finance part of it, the ROI you can get off on a standard machine tending solution now, with the right deployment, you can get it within 12 months. Maybe 18 months is maybe more on average. But like you say, you know, they don't. People seem to think it's a lot of money to spend, whether it's, I don't know, for example, 75 to 100 grand is maybe an average job that we might do. But actually, we say, well, when you actually look at the numbers, we say, well, you actually can't afford not to automate, because the ROI is, it's brilliant. You know, it's not just about getting more parts for the factory. It's, you know, it's the increases in the quality, the health and safety, all that sort of thing. So the one thing we do, you know, to try and prove to people what we can do is we get people to come here. So although we're selling, you know, machine tending solutions, we use them. We're our biggest customer. So our showroom is our shop floor. But it's just making people see that. I think a lot of people think we've had horror stories in the past, or I've heard of people that have had a robot in the past and someone's left and then no one knew how to program the robot. But it's not like that now. I think in the past, industrial robots used to be a bit more difficult to program. I've never really used them, but I mean, honestly, the cobots now are that easy, and I think the industrial ones are the same these days. That, you know, you could, anyone that can run a CNC machine can easily program a cobot or a robot to do machine tending.
Sure.
So it's just making people see that and believe it.
I think possibly, you know, in the early adopters sometimes get burned, don't they, in these kind of things. And maybe 20 years ago, 30 years ago, people bought a robot and then it sat in the corner. You know, it's a bit like a cross trainer that everybody used to hang their clothes on. You know, it's a similar kind of.
Yeah, we had a customer recently who was looking at getting a solution, and then he actually went to buy a machine from another factory, secondhand. And he was telling the person that he was going to see that he was getting some robot, like looking at getting a cobot in, and this person, whoever it was, said, "Oh, you don't want to be getting these." He's like, "I've had these 3 for however long, and they've not run for 5 years. No one knows what to do with them. They don't do anything." So, well, that's not what you're getting off us, or, you know, anyone else on this panel. It's not like that now.
Yeah, I think that is not in anyone's interest now. Any robot seller doesn't want a robot sitting there doing nothing, do they?
Yeah,
Okay,
exactly.
I'm coming to another question. So, how long does the safety case curation certification stage typically take? What percentage of the deployment life cycle? Who would like to answer that one? George. I knew he was looking
knew-
away. That's why.
I
Don't
knew
look
you were
away,
going to pick
George.
on me. Okay, this is quite a complicated one to answer.
Okay.
It's every case will be different. Every case, there are guidelines that we all have to follow. So it's for the robots, it's 10218 parts 1 and part 2, which ties into the machinery directives. So everything that we will do will be tied into those bits of legislation, and there's offshoots of that as well. There's directives for the guarding and so on and so forth as well. So when we look at each individual case, we have to compare to what it's doing to what bit of legislation is relevant, what the risk assessments say, and so on and so forth. And as long as it's not modified, once it's CE marked, then that should be good until something significant changes in the machine.
Okay.
As long as there's no major upgrades or major updates, once you get a major refurbishment, then you have to go through the CE certification again. But that's up to the integrator as to what, because there's no guidelines per se on what a major refurbishment is or is not. I know what my view is, but that's my view.
Sure. So are we, I know you can't say, oh, it's definitely going to be this or don't, but are we talking 6 months? Are we talking a year? Are we talking?
It's going to be different case by case. And
I
again,
knew he was going to say that.
that's because it is.
Try
I
help
wish
out
it
a
was
bit,
a hard and
Gail.
fast.
Gail, should I help
Yes.
out a little bit?
Yes,
Please.
Andrew, please
Not-
help out.
Not questioning George's what he's answered, but it is a CE self-certification system. But you can employ safety experts to do it for you.
Yeah.
They will look at the application and then they will work out a risk assessment and then mitigate against it, and then issue a CE certification. Equally, you can do it yourself. You can follow guidelines and do it yourself. So I think how long it takes depends when you start. I think you could. I think it's possible to probably a simple application could do it within a day. But you are still responsible. So ultimately, the factory owner has the responsibility, and there's also pure regulations as well that need to be considered. So,
Okay.
but CE is CE. You do it. You do the risk assessment, you mitigate, and then you certify it, and you keep a technical file, and that's it. Nobody really wants to see that file unless there's a problem, if you get an inspector come in.
Sure. Okay. So we're down to our last couple of minutes. I've got another question here. What points should we note when looking at a machine tending in harsh environments, e.g. high temperature environments? What should they be thinking about? Who would like to come in on that?
Yeah, I'll have a go at that one then.
Ben, go for it. Excellent.
So really, it's anything that's going to affect sort of any of the operation of the mechanical components in either the robot or the gripper that you're collecting with. So that could be anything from high temperature to dust to sort of submersing, anything that can get in there and affect any of the grease that's in those joints or any of the mechanical components inside. Ways we kind of get around that is potentially if it's a component that we're sort of dipping in a coolant wash, for example, having longer fingers so that we don't submerge the gripper. Or we can have covers on the gripper, shielding, things like that to kind of remove it from that area that's going to cause problems. In terms of dusting, you can have air purges on certain joints and things like that, and in the actual gripper itself to kind of stop anything getting inside. But again, we can also do covers and things like that to kind of mitigate that potential problem.
Okay, brilliant. Well, it's 14:59. Time has flown as ever. I would just like to say that if anyone's interested in taking this further, at MAC exhibition in April at the NEC, FANUC, Shunk and Cobots Online are all exhibiting there, so that would be a place to go and visit. There'll be a bar area, we think, as well, where you're probably going to meet George and Andrew as well. So certainly that would be a place to go if you're thinking of adopting machine tending or changing it, or whatever you want to talk about. That would work. I've just got to say thank you very much for attending. Thank you to the panel. If you could stay online and do a little answer the our little questionnaire at the end, that would help us for future events. And in the meantime, go on to bara.org.uk, where all the questions will be answered afterwards, and there'll be a show reel. So I've just got to thank the panel for your time, and thank you very much for attending. Thank you.
Thank you.
Thanks very much.
Thank you.